We'll proceed in vector algebra and calculus. Vector algebra and calculus. So, vector is a separate technology, algebra is a separate technology, calculus is a technology that works on algebra, and all of them they work on numerical mathematics. This is what we have seen till now. Okay, so this is what Okay, so this is what we have seen till now. So how they are in how they are dependent upon each other. Now question is arising that we are in discussion for path independence in vector field. We took example of a force vector. If there is a force vector, then how force vector is path independent? What we have learned till now, if I have a force vector and through force vector, if I want to calculate work done, makes sense? So if I have a force vector, okay, I have a force, I have a force vector. This is a force vector, and because of this force, there is a force, right? Because of this force, there is an item. It has started moving like this all of a sudden, or if it is kept like this, because there is a force, or consider this is a magnetic force. If this there is a magnetic force, and then there is an iron here. So iron, if the magnet is here, if magnet is kept here, magnetic force would go in this direction. Iron that is kept far away from the magnet, it will start moving towards the magnet. It would start moving towards the magnet. Okay, here is the magnet. Okay, if this is not iron, consider this is the big iron, and iron is this side, and iron can move only along the curve. Iron is bound in a way that it will move only along the curve. Now there is a magnet kept here, and magnet is kept in a way that magnetic field is in this direction. Now this iron would slowly it will start moving, and it will come to this end where it is nearest to the magnet. Means magnetic force is working. Magnetic force is attracting the iron towards itself. Nothing is energy cannot be destroyed. Energy changing its form. It's not that, oh, very nice, just keep a magnet and you see the item is moving from here to here for free, right? There is nothing. So if it needs energy to move from here to here, that much energy is gone from the magnet. Magnet lost that much energy. If I make this move now, okay, if that is the magnet, consider that I switch the polarity of the magnet. I switch the polarity. Consider there is another magnet. This is also a magnet. This is also a magnet, and this is south pole, and this side it is north pole in this magnet. The south pole would get attracted toward the magnet. If I switch the polarity of the magnet, then it will distracted, it will come here. If I keep on switching, it will start moving. Okay, so someone would say that for free we are getting the item moved in a circle, we don't need any energy at all. Not true. So energy is coming from the magnetic force. Magnetic force means magnet is losing its magnetization. So that's where energy is coming. Okay, if that is the sense, that's the where energy is coming. Okay, if that is the case, that's from where energy is coming. Now question is arising, what is path independence in force? If I have a force vector, then what is path independence in the force vector? What is path independence in the force vector? So that is in question mark. Okay. Now for path independence, we took example of Earth. Okay, so this, this is our Earth. If this is the Earth, then Earth magnetic field, Earth, whatever the field Earth generates, Okay, gravitational field. Then gravitational field is towards the earth from all the directions. Okay, gravitational pull is towards the earth from all the directions. If that is the case, then this is the force. Then if I keep any item here, if I keep any item here, then from here it will start moving toward the earth. Okay, what is the energy it is receiving? If it is still here and it starts moving, when it hits the earth, at that moment, what is the velocity? Half mv square. What is the mass? What is the velocity? That much energy it has when it is hitting the earth. This means that that energy came from where? Okay, that energy came from the earth itself. Earth lost the energy. If it is moving away from the earth, then it is something like earth gains the energy. Because as per the vector, if I go in reverse direction, then everything changes. Okay, this proves that earth is gaining the energy. If anyone is rising in its life, I told past last video also, if anyone is falling in its life, fall can happen in many ways. Then earth is not happy from you. But if someone is going up in his life or in the direction from the earth, then earth is happy from you because it gains energy from you. Whatever is the case, what is path independence we are talking about? So path independence is nothing but if this item comes from here and hits the earth, what energy earth is losing on this item? If this item moves in a round shape and then comes to the earth at same point, then what is the energy earth is losing on this item? If item is coming on a staircase and then it is hitting the earth, then how much earth is losing the energy? Earth is losing energy looking at the begin point and the end point. Begin point is how far from the earth and end point is how far from the earth. The path it takes to hit the earth, that does not matter. Earth loses same energy, begin point and end point. Now, if now this scenario is presented, now we will see how it looks as far as mathematics is concerned. So as far as mathematics is concerned, the work done by a vector force to move an item. Consider the item is moving from here to here, and this is the force. Then we have seen that work done by the force is capital F vector, force vector dot d of position vector of the displacement. Displacement is happening in a circle. There is an item that is placed here. An item starts moving from here to here because there is a force. Force dot product with d, that is calculus, d of the position vector. If I take any point here x comma y, if this is centered at the origin, from origin, if I draw a line from origin, if I draw a line to that point x comma y, this is called position vector. That is xi plus yj, that is constant, xi plus yj, where y is dependent upon x. In case of circle, it is y equal to square root of a square minus x square. A is the radius of the circle. Understood? So that is the scenario. If it is a straight line, then y equal to something in x. That is different. If it is a curve, y equal to something in x. If it is a parabola, y equal to something in x. But generic position vector, the generic position vector is xi plus yj. Generic position vector is xi. So the net energy that is going away from the source from which I am seeing the force vector is capital F dot d of position vector xi plus yj. F, if capital F is represented, capital F is the force vector, is represented since a vector, it has to be represented as orthogonal component. So that is F1i plus F2j, where F1 is the x component of F, and F2 is the y component of x, j component of x, and I component of the F. Capital F1i plus capital F2j equal to F, that is the force, capital F. F1 can be a function over x and y. F2 can be a function over x and y. This is algebraic vector. So capital F dot dxi plus dxj, d of xi plus yj is like that. and capital F is F1i plus F2j. Net becomes F1 dx plus F2 dy. That is the inner integration from 0 to x whatever, beginning point to end point where object is moving. Okay, if that is the case, then this is the energy that energy source is losing. That much is the work done from the energy source. That is lower limit. Lower limit is this. That is 0 and a. That is the lower limit. If it is moving up till here, then it is a comma 0. 0 comma a to a comma 0, and then f1 dx plus f2 dy. Okay, now what we saw, another point we saw that if there is any algebraic equation small g of x and y, algebraic equation function of x and y, small g, and in braces x comma y, braces close, small d. Okay, if that is the case, then dg by dx equal to f1 dx plus f2 dy. Consider that this integration f1 dx plus f2 dy, whatever the integration, whatever the energy computation we are making, irrespective of the limit, this will come to one integral. This integral is an algebraic equation gxy. If it is resulting in gxy and dg by dx is f1 and dg by dy is f2, then I can represent it as dg by dx plus dg by dy dy. If that is the case, then it resolves into g. dg by dx plus dg by dy plus dg by dy would resolve into g. Okay, then if it resolves into g, this integration resolves into g. Okay, this integration would resolve into dg by dx into dx plus dg by dy into dy, dx gone, it will result into dg. dg integration is g, and then limit. Makes sense? So if I have a energy calculation that is d that is f1 dx plus f2 dy, where f1 and f2 are two components of force vector f, and full integration resolves into gxy, that is algebraic function. Okay, if that is the case, then dg by dx, f1, if I replace f1 as dg by dx, f1 as dg by dx, and f2 as dg by dy, then it settles down in g only. This is as per fundamental. Where is that? If that is the case, then g, whatever we are getting g, I would repeat it again. So now work done is capital F1 dx plus F2 dy. That is the work done. That is the energy that is coming out of the earth. Okay. And if this full integration is g is an algebraic equation. Full integration is g. Then F1, if I represent F1 as dg by dx, it's not possible always. If the end result, this is f1 dx plus f2 dy. If I integrate f1 dx plus f2 dy and it comes as g, then dg by dx, not necessarily it will be f1, not necessarily. dg by dy, not necessarily it will be f2. Consider it is like that. If I am getting integration and that is g, and consider luckily, in a luck, that dg by dx is f1. This is a luck. dg by dy, partial derivative is f2. Then I can replace there. Now f1 is dg by dx and f2 is dg by dy. dx gone, dy gone. It will more or less dgx. dgx integration is gx only. Now gx, I have to set the limit. This proves that if that happens, for God's sake, luckily, if f1 equal to dg by dx and f2 equal to dg by dy, then the g, what we are seeing, it is completely dependent upon f1 and f2 only. dx and dy are representative of the position vector of the path along which item is moving. If you remember, the energy that is produced by the energy source, that is energy that is produced by energy source is vector force vector dot d of position vector. Position vector can be represented any point on the curve along which the item is moving can be represented as x comma y. Position vector will be xi plus yj. Capital F, capital F is the force vector dot d of xi plus yj, that is dxi plus dyj. dxi plus dyj is representation of the displacement, where capital F is representation of force vector. If I do dot, then it becomes f1 dx plus f2 dy. If that results in a function called g integration, and for luck dg by dx is f1 and dg by dy is f2, then full integration what we did, we can just represent it as g only, simple g only. Anyway, it is g only. If that is the case, then then we can just set the limit from a to b in the g, and we get the net integration, net energy. What we are seeing here, if f1 is dg by dx and f2 is dg by dy, means whatever integration we are getting, that is only dependent upon f1 and f2, means only on the force vector. And if this is the scenario, then net integration g, that is dependent upon f1 and f2, the net energy we need to find, that is from lower limit to higher limit. So this is lower limit to higher limit, and lower limit is a and higher limit is b. A to b of g, g in the net integration algebraic function, g and lower limit a to b. What we get, that is the net energy that gone from the energy source, or it receives the energy, whatever it depends upon the vector direction. So if that is the case, then g lower limit a and b, and g, so net integration what we are saying, it is dependent upon g, a and b, and g is dependent only upon f1 and f2, because dg by dx is f1, dg by dy is f2, not always. If that is the case, then this is considered as path independent force field. Force field is path independent in the sense that net energy calculation is dependent upon the force field and lower limit to higher limit only, not on the path. So if I prove any force vector field as path independent, then it is considered as that energy dependent upon the beginning point and end point. This is what we saw. Okay, if that is the case, then what is the force field of Earth? That is minus g, that is gravitational pull, that is 9.8 meter per second square, minus g, because Earth pulls toward itself. If it is throwing away, then it will be plus g, minus gm. M is the mass of the item that is getting pulled. That much energy Earth will lose. If mass is very big, then Earth will lose more energy. If mass is a feather, mass is a feather or a cotton, and it drops on the earth, then earth is losing less energy. Okay, so if that is the case, then mass kind of minus gm r vector. R vector is the direct, this is r vector, everywhere this is r vector. R vector is a radial vector away from the earth. So if I take any point on the r vector, that this will be xi plus yj plus zk, because that point is x comma y comma z. Then r vector can be represented as xi plus yj plus zk. Then now we know that the gravitational force of the earth is minus gm r vector divided by r to the power 3, whatever the magnitude, the distance at which it is. If this is x comma y comma z and this is earth, then center, from the center of the earth, whatever is the distance, that is x square plus y square plus z square root to the power 3, that is the gravitational pull of the earth, minus gm r vector divided by r to the power 3. If this is the gravitational pull, then what is the energy that is gone from this? So to calculate the energy, force vector dot d of displacement vector. This is what we have seen. So if I take any point x comma y comma z, then displacement vector is xi plus yj plus zk. Sorry, position vector is xi plus yj plus zk. Net energy calculation is force vector dot d of position vector. So position vector is xi plus yj plus zk, or r vector. So force vector dot d of r vector. Force vector is minus gmr vector. Force vector is minus gmr vector divided by r to the power 3 dot d of r vector. Integration is lower limit to higher limit. From what radius? Radius will be in length only. From what radius to what radius it is moving, that much is the work done from the earth. That much earth is losing the energy. Then gmr vector, gmr vector, gmr vector, dr vector. Since r vector and dr vector, they are in same direction. So r on top of r, I can take out the vector, not required. Like xi dx, xi dxi will become x dx. Similarly, it will become minus gmr dr, because r vector and this r vector are in same direction, dot product. Now minus gm I can keep outside, and now integration is from one point to another point, r dr divided by r to the power 3, 1 by r square. Integration is r to the power minus 1 by minus 1. Minus is outside, gone, and then 1 by r. So net energy that earth is losing is gm by r. Net energy that earth is losing is gm by r. Lower limit to higher limit. Makes sense? Now, we were giving example, we are in midway to giving example that consider this is x-axis, this is y-axis. Now, there is a line that intercept x-axis at 3, 0, y-axis at 0, 3. This is the line. If this is the line, there is one item that moves from here to here. How much energy earth is losing? So consider that this is the line. This is x-axis, this is y-axis, this is x-axis, this is y-axis. Up, x-axis, y-axis. Then there is a line like this, and line connects 3, 0 here and 0, 3 here. If that is the case, then item is moving like this. How much earth is losing the energy? Now the question arises is that if I want to calculate it, how much earth is losing the energy, that is gm by r, from lower limit to higher limit. This is the energy we saw. Gm by r, lower limit to higher limit. The lower limit here is 0, 3. Lower limit is 0, 3. If I consider this x-axis, I set x-axis and y-axis. Consider this is x-axis, this is y-axis, and this is z-axis. Then this point is here, and this plane, xz plane, this is xz plane, this is yz plane. In this xz plane, this point is, consider it is at y equal to 0. Then this point is 0, 0, 3. Yes, and this point is 3, 0, 0. A line connecting 0, 0, 3 and 3, 0, 0. From here, an item is moving like this. If item is moving like this, how much earth is losing the energy? Then if I consider that this is this is the earth, and line is this is the x-axis on the earth, which it will be flat only because earth is very big. Line is like this, and this item is moving like a diagonal fashion from here to here. Then if I see this distance from the earth here, then this is the radius of the earth, whatever it is, plus 3. And here, if item is moving here, this is the radius only, because that is on the earth only. So if I want to calculate energy, then it is gm by r, lower limit to higher limit. Lower limit is 0, 0, 3, and higher limit is 3, 0, 0. Okay, now 3, 0, 0 is radius of the earth only. Okay, so that is the situation, and 0, 0, 3 is radius of the earth plus 3. Okay, so one I say r, one I say from here to here, right? So one is r plus 3, radius plus 3, and 2 r. Okay, so net energy earth is losing is gm by r, that is the radius from the center, r plus 3. R plus 3, the net energy earth is gaining or losing is gm by r plus 3 minus gm by r. I believe it will come as negative. will come as a negative because Earth is losing energy. If someone is pushing from here to here, then lower limit is this. Then R to up. Okay, I said if it is coming from here, lower limit coming from here to here. Okay, lower, this is lower limit and this is the, I'm sorry. Then lower limit is R plus 3 and higher is R. Okay, then it is Gm by R minus Gm by R plus 3. Gm by R plus 3. It is positive. Okay, whatever. But Earth is losing the energy. Earth is losing the energy in positive sense. This is what I can say. So this is the work done by the Earth. Work done by Earth initially we took as a negative sign. So work done by the Earth, force we have taken in this direction. Okay, what there is a work. If I say what is work done by the Earth, then this is coming as positive. But Earth is losing the energy. How much it is? Gm by R. Gm by R, that is the upper limit. Gm by R plus 3. Denominator is high, means this value will be G, lower limit to higher limit. Lower limit to higher limit. So higher limit will come first Gm by R minus Gm by R plus 3. So Gm by R will be more and minus Gm by R plus 3. Okay, that will be less. So more minus less is positive. So this much is the work done by the Earth. Whatever someone takes, so this much Earth is losing energy. Now, if someone is taking it up, then it will lower limit is R and higher limit is R plus 3. Gm by R plus 3 minus Gm by R. R plus 3 is less and R is more. Negative. Means work done is against the Earth, but Earth would gain the energy in this fashion. Okay, so this is the work done. Now can we prove why I can say that dg by dx into dx plus dg by dy into dy is gx? This is the question that is arising. Or the energy calculation is f1 dx, energy calculation is f1 dx plus f2 dy. Energy calculation is f1 dx plus f2 dy. Then if how f1 dx plus f2 dy and it is path independent, then dg by dx is f1, dg by dy is f2. How we can prove this? So that is the question mark that is coming. Now to prove it, now people have found many ways. One way is, consider there is a point called a comma b. Consider this is xy plane. There is a point called a comma b. There is another point here called x0 comma y0. A comma b, x0 comma y0. Now to reach a dot b to x comma y, x0 comma y0, then can be two paths. One path is goes vertical like this, and from there draw a horizontal like this. Then you reach x0 y0. If this is a comma b, then this point is a comma y0, a comma y, because x did not change. Then this point is x0 y0. Now if I get the work done along this path, then it is addition of this line integral, addition plus this line integral. This line integral, if I see, then there is change only happening in y direction. So it is capital F dot dxi plus dyj. That is the work done. Capital F is f1i plus f2j. f1i plus f2j dot d of xi plus d of yj. If we do dot like this, then there is no dxi, because it is moving in this direction. This point is a comma b, then this point is a comma y0. So if it is moving in this direction, there is only, okay, if I see the position vector difference, this, if I draw position vector, this is a comma y0, this is a comma b. What is the position vector? a minus a 0. There is no x component. Y is y 0 minus b. So if that is the case, then dxi, that is gone. So it is only f2, this is only f2 dy. So line integral, work done from here to here vertical is f2 dy. Similarly, work done from here to here is f1 dx. Now f2 dy from point a comma b to point a comma y0, and this work done is from point a comma y0 to point x0 y0. Now if this integration is g, this is what we are saying, gxy g. What is dg by dx when x is x0? At this point x0 y0, what is dg by dx when x is x0? If that is the case, dg by dx, then first term, that is f2 dy, is gone, because there is f2 dy. F2 dy integration is from a comma b to a comma y0. There is no x0 involved. So this term is completely gone. Next term is f1 dx a comma y0 to x0 y0. Now there x0 is there, so this will retain. Now differentiation of this dg by dx and integration of f1 dx will become f1 only. So in this case, dg by dx is f1 only. dg by dx is f1 only. Similarly, if I have this point and this point, if I take another path, one path goes in horizontal direction first and then vertical direction next. So if it is a comma b, then this is x0 comma b, and this point is x0 y0. Now if we repeat same thing, then line integral, since it is path independent, right? We take this path and this path, and then we take this path and this path. Since they are dependent upon these 2 points only, then dg by dx will work here. Now dz by dy, so g equal to, now in this case, since it is path independent, it should matter between, if it is path independent, I can break into any path. If these are the 2 points and it is path independent, I can make so many paths reaching one point to another point, path independent. So one path and then another path. So in this path, if I calculate the integration, then it is f1 dx from point a comma b to point a comma x0. Or next is f2 dy from point a comma x0 to y0 x0 or x0 y0. Okay, from point a comma b to point x0b and point x0b to x0y0. Now if I say dg by dy in this path, then first will go away, because it is from point a comma b. Point a, this point is x0, this point is x0 y0. Okay, now from point a comma b to point x0b, x0b to x0y0. Now if I integrate the first path, will be f1 dx from a comma b to a comma x0 comma b. Now plus point x0b to x0y0 f2 dy. Now if I say dg by dy at y equal to y0, first will go away because there is no y0. Second term will come as f2. So dg by dx is equal to f1 and dg by dy equal to f2 if I have not taken the path into the consideration. Only these 2 points I am taking, a, b and x0. So this is the explanation for the y f1 equal to dg by dx when it is path independent, and y f2 is dg by dy when it is path independent. Anyway, we'll try to see if there are other proof possible. Then we will see more in the path independent. Why we are doing this much into vector analysis? We are progressing in the sense we are taking new things. If vector fundamental is clear, and then algebraic vector and calculus, then this is the end of the universe. So this is the ceiling, the last point. If someone is cracking this, then everything is like a cakewalk. Anyway, please do support us. Plus 91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India